You will need to remember all of your factoring rules in order to be successful with what we're going to continue doing. And the very first thing that I want to point out that students always want to do is when they see something that looks like this, immediately they want to do this. You are not allowed to do this. You may want to say out loud, I am not allowed to cancel anything that is not a factor. Hopefully you said it. What you need to do instead is you need to factor each one of these polynomials. So the numerator so that's a minus and a plus. How do I know this works? Well, I multiply it out in my head. 5a squared, that's plus 5a, plus 4a, minus 1. In the denominator, I see that first I can factor 5 out of this. So so it's minus 2, so the 3 is here, the 1 is here. Now a lot of you are going to want to try and plunk this back in to see if you can get something to look like that. It will not happen. Instead, what you should recognize is you have a plus 1, a plus 1. Those cancel. Taking a look at the next one, you should notice that there's an exponent of negative 1. That means this whole factor moves to the denominator. Out of my numerator, I can factor z squared. Out of my denominator, I can factor z. And from here, I can factor. Now maybe you notice I've got z minus 3 and 3 minus z. What you are allowed to do here is you're allowed to factor a negative 1 out of this, and that turns this into z minus 3. Once you've done that, this cancels. You cancel 1z here. You end up with negative z times z minus 2 over 3 plus z. And that negative really can go anywhere in the fraction. Here you're seeing a rational function, which just means that it's an equation where you've got variables in the numerator and the denominator. The first question is to find the domain. Domain is always going to be represented by the zeros of the denominator. So either 2x has to equal 0, x plus 3 has to equal 0, and x minus 3 equals 0. That means that x is either equal to 0, negative 3, or positive 3. What this means, our domain of G, is that x may not be equal to any of those values. As a part of the domain, because if that's the case, it will zero out the entire denominator, and then you'll have a 0 in the denominator, which does not exist. So if you're looking for the domain, you find the places in the denominator that will make it equal 0, and those values cannot be in the domain. Finding the zeros then is quite a bit easier. The zeros are going to be where your numerator is equal to 0. So either x plus 4 or x minus 1. So those are your zeros, -4 and 1. All right, I'm giving you this as a reminder. Remember that when you multiply fractions, you multiply your numerators, you multiply your denominators. When you are dividing fractions, we copy, dot, and then this gets flopped. That works even with polynomials. So the first one we'll start with is actually pretty simple. We just multiply straight across. So we have 2x squared y times b cubed over 2x y a. We can cancel because everything here is being multiplied. The y's cancel, and 1x cancels, and the 2's cancel. So we are left with, in the numerator, x b cubed, and in the denominator, we're left with a. When you have polynomials, this is a little bit trickier, and what I recommend that you do is factor everything first. So this first one, I can factor out an a squared, and in the numerator of the second one, that can be factored as well. In the denominator, I've got a cubed here, and then I can factor. Oh, the 3 doesn't go there. So now I've done this, I can simplify. 2 a's go away here, leaving me with 1 here. I have an a minus 1 and an a minus 1. Nothing else factors out, so what I'm left with nothing else factors. Occasionally, you'll see problems that look like this. The first thing that I recommend that you do is rewrite this second one as its reciprocal, and then factor, simplify, all those other things. So that would be written 1 minus x squared over 3x plus 4 times 9x squared plus 24x plus 16 over x squared plus x minus 2. Now I can factor, and I should recognize that the first here is a difference of squares. And then the next polynomial is actually a perfect square, and the reason that I know that is because I recognize that 9x squared is a perfect square, 16 is a perfect square, so that's actually how I know that that's where I'm going to start. And then I check just to make sure, 12 plus 12, 24. In the denominator, I still have 3x plus 4. And then I factor the second trinomial. I know that the 2 is positive because I've got plus x here. Now that I've done, I can start canceling different things. I noticed that 3x plus 4 canceled. Now again, just like in the last problem, I have 1 minus x, and then I have x minus 1. So what I can do is I can factor negative 1 out of here, and then I can turn this one into 1 minus x. Now, these will cancel. When I rewrite this, that negative 1 can go in the numerator or the denominator. It ends up just being negative. You'll often see things looking like this, where it's a fraction inside of another fraction. It's still a copy dot flop sort of situation, because really what's happening is we have y squared minus 5py plus 6p squared over y plus 2p divided by y squared minus 4p squared over 1. So when I copy dot flop, so there's copy, there's dot, now I can start my factoring. I'm working on this portion right here. And just to make sure, that's y squared minus 3py minus 2 more 3py, so that makes it minus 5py plus 6p squared. And then, of course, difference of squares happening here. This cancels, and that's all we can do here. So then the final answer we can write it like that if we'd like. Okay, so last problem, you might see this just with variables. You may also see it with polynomials, but really very few things actually change. So I'm going to copy dot flop. So I copied the first things. There's my dot. I'm going to flop this one. Once I do this, I'll combine things as best I can, and then I'll start canceling. So I have r to the 4th, s, t to the 4th. In the denominator, I see I have r squared and just r, because this is an s, even though it doesn't look like it. So r squared and r gives me r cubed. There are 2 s's, so that's s squared and 1t. If you write everything in order to the best of your ability, obviously it's going to help you see better. So there are 3 r's here. If I take away 3, I'm left with 1. 1s, so I take away that one. Here I've got 1t, which means that this leaves me with t cubed. So I have r t cubed over s.